Good afternoon, everybody. Welcome to online learning. This is our ninth lesson since we started our online class. This presentation was prepared by foreign teachers in Pratum Suksa 6, Anuban Chunbury School. This video recording is for educational purposes only. My name is Teacher Edward. Once again, I am your science and your health teacher. Okay, so who can still remember what did we study last week? Last Wednesday. Can you still remember what did we study last time? Anybody from the class who can tell me? What did we study last time? If you have your book with you, can you check if we are done with page 37? Can you
Yes.
confirm if we are done with page 37?
Yes.
So what page are we now? Or I mean, what is page 36 and page 37 all about?
Precipitation. Precipitation.
Okay, it's all about precipitation. Okay, it's all about precipitation. Okay, so we studied last week about what is precipitation, how does precipitation works, and what are the uses of precipitation in daily life. All right, so these are the list of the vocabulary words that we've learned last week. Okay, we have precipitation, alum, or that is the short name of aluminum sulfate, if you can still remember. And we have coagulant, purify, decantation, clamp, and disinfection. Okay, these words are the words that we studied last meeting. Okay, now our topic for today, if you flip your book in page 38, if you open it in page 38, uh, we will be discussing all about, what can you read there in page 38?
Evaporation.
Evaporation. Okay, so I'm sure that you are familiar already with this evaporation, right? Because all of you maybe can recite the water cycle by memory. Okay, so of course evaporation is part of the water cycle. But this one, how does evaporation separate things? Because this is one of the separation techniques that we studied throughout our lesson in this chapter. Okay, so this afternoon, in the context of separation techniques, what is evaporation? How does evaporation works? And what are the uses of evaporation in daily life? Or what are the uh, effects of evaporation that we can see or use in our daily life? Okay, so before we are going to start to dig deeper in our study this afternoon, I will let you watch this short video. Wait, I will check if okay, share sound.
Welcome to 3D8. In this video, we are going to discuss the distillation process. Distillation is a combination of two opposite and independent processes: evaporation and condensation. Evaporation is when a liquid gets heated to its boiling point and turns from a liquid into a vapor. For example, when you boil a kettle, the water gets converted into a vapor simply because of the heat added to the liquid. Condensation is when vapor gets converted back to a liquid. An example of this is when water vapor collects on the window. The temperature outside the window is colder, and therefore the water particles in the air turn into a water vapor. When both of these processes take place one after the other in a controlled manner, distillation occurs. There are many applications for distillation. The one we will be discussing is how to extract salt from salt water. First, we will talk about the experimental setup that is used in most labs. This is a stand and a boss, which holds the setup. This is a round bottom flask. It holds the salt water. It has a thermometer and bung at the top, so the water vapour doesn't escape. The round bottom flask has two chambers, one evaporation chamber and condensation chamber. In the evaporation chamber, the water from the salt water will evaporate towards the condensation chamber. The temperature inside the condensation chamber will be low due to the continuous flow of water inside the cooling chamber. It's connected to a beaker at the end which will collect the condensed water. This is called a Bunsen burner, which is used as a heat source to heat the salt water. Now the experimental process. Switch the Bunsen burner on. Turn the cold water tap on. Once the tap is switched on, the water will flow from the inlet pipe and come out the outlet pipe. Make sure there is no leakage around. Inside the round bottom flask, once the water starts getting heated, the temperature of the water will start to rise. This is indicated by the thermometer. After the temperature starts to increase, the water will start evaporating slowly. As the temperature further increases, the evaporation will be more intense. When it reaches 100 degrees, the water will start boiling and evaporating a lot. When the water evaporates, the vapour will have nowhere to escape and will have to pass through the round bottom flask's throat. As the vapour passes through the condensation chamber, the temperature inside is low, so the vapour will convert back to water, and because of the slope of the chamber, the water will flow down. This water will start getting collected in the beaker. Remember, this water will be free from the salt. On the other hand, as the water keeps boiling and evaporating, salt will start to appear on the bottom of the round bottom flask, as the water will start to become saturated, so any excess salt will start appearing and gradually increase in proportion to the loss of water. This process will continue until the whole of the water is evaporated, condensed, and collected on the beaker. At the end of this process, the salt will remain at the round bottom flask and the water will remain at the collection beaker. This concludes our video. Thank you for watching.
Okay, so I will go back a little bit
Water will start to be
so
beaker.
that you will be able
Water will start
to
evaporating
understand
slowly. The
properly.
vapour will have nowhere to escape.
Okay, so right here, oops, I will try to, okay, here. I will try to share something here so that we will be able to understand this properly. It says here that distillation, have you heard of the word distilled water? Have you heard of the word distilled water? Anybody heard like distilled water? Yeah, right? So distilled water comes from the distillation. Okay, so distillation process, and this distillation process involves two processes. Okay, first is evaporation. Okay, and another one is condensation. Okay, so if you're going to add these two processes together, then we can see the result or the distillation happens. Now, the question is, where is the uh, evaporation here? So the evaporation process is when you're going to burn or to going to apply heat in this salt and water solution. Okay, so when this happens, the water will turn into uh, gas or steam, right? It will turn into a steam, then it will go up. Okay, it will go up. Okay, now since it is locked right here, since this thing is locked, okay, so there is nowhere for this steam or gas to go besides this condensation chamber that we can see here. Okay, so this is the condensation chamber. Okay, I will put a line here. So this is the condensation chamber. Okay, now this condensation chamber, it will the temperature here, temperature uh, will start to go down. Okay, what happened? The temperature here, the temperature of the steam will start to go down, and you know what will happen to the water or to the steam if the temperature starts to go down? It will become water again. Now when this becomes water again, it will flow in this condensation chamber, and then it will become a water. Okay, so the factor here is the temperature. All right. Now, if you're going to separate, or the things that we can separate here is the salt. Okay, the salt will remain in this. Uh, oops. The salt will remain here. The salt will remain here because the salt will not evaporate. Okay, so the salt will remain here, and only the water will evaporate. Okay, now when that happens, we have two substances that we able to separate: the salt and the water. Okay, so I hope you learned something from that. Let's proceed to our vocabulary words for today. uh Something wrong with my, wait, something wrong with my PowerPoint. Give me 1 minute. Okay. Okay. So that is the process of evaporation. Okay. Let's click it again. Sorry for the interruption. Okay. So okay. So as you've noticed, there are words there that are new to you, and I will explain, or uh, it will be part of our vocabulary words segment. Okay, the number one, I'm requesting all of you to please turn on your microphone. Please turn on your microphone, and I want you to repeat each word after I will read them. Okay, so we have number one. Number one is distillation. Okay.
Distillation.
Distillation.
Okay, thank you. We have number two, condensation,
Condensation.
Condensation.
evaporation,
Evaporation.
Evaporation.
boiling point,
Boiling
Boiling
point.
point.
saturated,
Saturated.
Saturated.
dissolved,
Dissolved.
Dissolved.
seawater,
Seawater.
Water.
freezing point,
Freezing
Freezing
point.
point.
Facing
salt,
point.
salt,
Salt.
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 soluble,
Soluble.
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 soluble. Okay, thank you. So you can mute all of your microphone now. Okay, so the first word here is the distillation. Okay, I already explained what distillation is. It is the action of purifying a liquid by a process of heating and cooling. So here we apply heat, and here we apply uh, cool. Okay, or because of the condenser, the water is steam, it will go back into water again. Okay, so distillate is the thing that we called with the water that will drop here, or the water that will go here, we called distillate. Okay, so that is the process of distillation. Next is condensation. Okay, condensation is happens when the water which collect as droplets on a cold surface, or when humid air is in contact with it. So as you've noticed, this uh, gas here is in the boiling point, so that's why it's very hot here. It's very hot, so it will evaporate 100 degrees Celsius, let's say. And when the steam will go here, the temperature drops. What happened to the temperature? The temperature drops. Now the steam will start to become water on this condenser. Okay, and then it will become like this. Okay, So that is the process of condensation. Now evaporation. I won't explain this too much because I'm sure you are familiar with what is evaporation. The process of turning from liquid into vapor. Okay, so that is evaporation. Now this is the boiling point. Okay, it is the temperature at which a liquid boils and turns to vapor. If I'm not mistaken, the water will boil at 100 degrees Celsius. Okay, what about natawat? If we are going to let natawat evaporate, I don't know, maybe 1000 uh, degrees Celsius. We don't know. So different liquids have different boiling point. Okay, some liquids can can will not be able to be undergo boiling point unless it will hit like 120 degrees Celsius, 150, something like that. So it has different boiling points with different liquids. But for our example now is only water. So the boiling point of water, if I'm not mistaken, is 100 degrees Celsius. Okay, saturate. This is a little bit difficult to explain. I want you to listen carefully. It is a verb to cause something to become thoroughly soaked with liquid so that no one can be absorbed or no more can be absorbed. Chuntida will have a water, and that water Chuntida will add salt. Okay, and then Chuntida will mix. Okay, then after all the salt will melt or dissolve, Chuntida will add salt again. Okay, so when you add it over and over again, there will come a time that even if Chuntida will add more salt, the salt will not be able to be to dissolve. I will repeat, there will come a time if you keep on doing that process over and over again, adding salt, it will not be dissolved anymore. Why? Because the solution is saturated already. Okay? So that is the meaning of the word saturate. And the next word here is dissolve. To become or cause to become incorporated into a liquid so as a form of a solution. So what is the best example for the word dissolve? Salt, right? If we add salt, then the salt will be incorporated with the liquid. Uh, is the chalk? In our study last time, we studied filtration, right? You still remember filtration?
Yes.
Okay. Can we do the filtration so that we can separate the salt and the water?
No.
No, right? Because the salt is incorporated into the liquid. So we need to have a different technique. Okay. What about chalk? Okay, what about chalk? Is the chalk soluble or insoluble?
Insoluble.
Okay, so the chalk is insoluble. So we can do the filtration. Okay, now this is the seawater. Seawater is a water in or taken from the sea. Okay, so it's very simple to understand. Okay, seawater. The next one here, the next word is freezing point. Okay, so the freezing point is when the temperature at which the water changes from liquid to a solid. Okay, liquid becomes a solid. For example, the water here, when there is a 0 degrees Celsius, then the water becomes ice. Okay, so the equivalent of 0 degrees Celsius is 32.5 degrees Fahrenheit. So that is the freezing point of water. Okay, you still remember this guy? Okay, the next word is salt. Okay, so maybe Jirayu wants to become like this when Jirayu will become bigger. Okay, so salt is a white crystalline substance that gives seawater its characteristic taste, and it is used for seasoning or preserving food. Now, I want to tell you something very interesting. Before, salt is very expensive. Okay, it's not the same right now, right? You can just go 7-Eleven and then you can buy salt very cheap. People before, they need to travel from Europe, Nataya. They need to travel from Europe, and then they will bring salt, and then they will go to China to sell the salt. And when they sell the salt, the Chinese people will give gold. Will give what? They will give gold in return for the salt. Okay, so maybe Nataya, you have gold, then I will give you now a salt, and then you can give me the gold. Huh? Maybe. But that is what it is happening before. But it is it totally changes now. Okay. But I'm telling you that salt before is a very expensive thing. All right. Now let's proceed to the word soluble. I'm sure we studied this one many times already, but I want you to understand. Able to be dissolved, especially in water. Example here is dissolved or soluble is a salt. Okay. Now time for our quiz, for our vocabulary words. Now I want you to uh, look for the words here, and please tell me, or you can say, me teacher, I want to answer. Let's do it one by one. Again, I want you to do the rectangular thing, okay? I want you to do the rectangular thing. And let's find the word soluble first. Who can find the word soluble? Who can find the word soluble? Who can find the word soluble? Yes, Chuntida, go ahead. Make a rectangle and try to do something like this, okay? Or yeah, like something like that. Rectangle. Go ahead, Chuntida. Very good. Okay. Oh, Tanakit did. Tanakit, do not do it, Tanakit. I asked Chuntida to do it. Okay. Soluble. Thank you, Chuntida. Soluble. I give you points. Okay. What about who can find the word boiling point? Please raise your hand. Natawat. Natawat, go ahead. Natawat. Find the boiling point.
Around where, but I can't draw.
You cannot draw, or maybe where is it? Where is it? Maybe I can help you. Or let's ask Pirapong then. Pirapong, go. Put it inside a red rectangular shape. Pirapong, go ahead. Okay, very good. Oops. Okay. Can you delete that one, Pirapong? I will try to make a new one. Okay, thank you. Boiling point, very good. Let's try saturate. Who can do or who can find saturate? Let's ask Piradich, number 39. Saturate. Piradich, number 39. Can you find the word? Okay, very good. The word there is saturate. Please delete that one, Piradich. I will use the red one so that it will be easier for us to see. Okay, and it will not become very dirty. Thank you. And the next word is evaporation. Who can do the evaporation? Let's ask Don Raporn. Don Raporn, can you find evaporation? Go ahead, Don Raporn. Okay, Don Raporn. Where is it? Yes, Don Raporn. Find the word evaporation. Thank you. Very good. Very good. Okay. Next is seawater. Let's ask Pichaya. Napichaya, go ahead. Number 30. Find the word seawater. Okay, very good. Thank you. Napichaya, can you delete that? I will make it beautiful. Okay, good. Napichaya, you can lower your hand now. What about the word distillation? Let's ask someone else for the word distillation. Let's ask Putisan, number 1. Please do it, number 1. The word is distillation. Where is the word distillation? Who is number 1? I think number 1 is raising its hand, but I cannot see it now. Okay, maybe we'll call someone else. Okay, Putisante, very good, Putisan. Can you delete that, Putisan? I'll change it into the red one so that it will be uniform. Thank you. Okay, so what about the freezing point? Who wants to do the freezing point? Purama, this time Purama. Let's give chance to some of our friends. Purama, please do it.
Teacher, I know, but I don't know how to make a rectangle.
Oh, you don't know how to do the rectangular. Okay, so let's ask someone else. Jirayu, go ahead, Jirayu. Find the word the freezing point. Okay, there, thank you. Can you delete that one? I will try to make it uniform with a color red. Thank you, Jirayu. Okay, good. The next word here is the word dissolve. Who wants to do the word dissolve? Chuntida, you haven't answered yet? Okay, go, Chuntida. Dissolve, where is dissolve? Okay, thank you, Chuntida. You can delete it now. Okay. Okay, good, perfect. What about the word salt? Where is the word salt? Let's ask Jinipa. Jinipa, can you find the word salt here?
I cannot do the rectangle.
Oh, you cannot do the rectangle, but you can write. Can you write, Jinipa? You can write. Then I will just delete it after. I just want to see where is it. Okay, salt. You can write something. Is okay. Put it in a oval or something. Then I will do the rest. Okay. Where is it? Cannot find. Cannot do it. Not Jinipa. Let's ask Nataya. Go, Nataya. Nataya is about to cry because I wasn't able to call her. Go, Nataya. Go. Woo, very good, Nataya. Good job. Good job. The line is very small. Okay. So they're perfect. What about the last one? Condensation. The word condensation. Let's call someone else who wants to try. Maybe those. What about Parinya? Can you do it, Parinya? The word condensation. Parinya, number 10. Do you know how to do? Even if you can do like this, it's okay because I will just change it. You know, even if you can write something like that, it's okay. I will try to fix it. Parinya, can you find the word condensation? Cannot find Parinya. Let's ask Satawit. Do you know where is it, Satawit? Okay, go ahead. Condensation. Okay, let's wait for Satawit. Okay, thank you. Thank you, Satawit. And good. Clap your hands, everybody. You did a good job. Very good, very good, very good. Good job. So I will remove all of this. Thank you for your cooperation. And we can now proceed to the next segment of our class this afternoon. Okay, great job. So our topic for this afternoon is how can we separate a soluble solid from a liquid? Okay, so this is found in your book, page 38. So if you have your book with you, I want you to open it in page 38 and I want you to ready your highlighter as well. Okay, ready your highlighter as well. Okay, so I have a question here. Can you tell me what is the meaning of the word soluble? Or can you give me an example of a soluble solid?
Salt.
Yes, Nataya, what is a soluble solid?
A solution can dissolve in water.
Okay, can you give me an example of a soluble solid?
Salt,
Very good. What else besides salt?
sugar,
Okay, what else? Maybe you're thinking of coffee. Yeah, coffee is okay. Milk as well. And then you're going to mix everything. Then you will make milk tea. Okay, so very good. Thank you, Nataya. Of course, salt is a soluble solid. So we can separate it from a liquid by using a different technique, evaporation technique. Okay, so I want you to highlight this sentence. We can use evaporation to separate solids dissolved in a liquid. Okay, so I want you to highlight that. I want you to highlight that. Okay, and okay, perfect. And it says here, evaporation has been used to obtain salt. Okay. So people long time ago, they've been using this technique of evaporation to separate or to get the salt from the seawater. Okay. So they get this salt from seawater and they use evaporation. Now, have you seen this before or anybody went to Pichaburi before and saw this salt farm there? Okay. So this is a salt farm in Pichaburi province in Thailand. Okay, so this is here. In the Philippines, I'm sure we have like this as well, but I haven't seen this very wide and very massive salt farm. But here in Thailand, I saw it when we know when we traveled in Pichaburi maybe a year ago or 2 years ago. So I saw this one, and it's very nice. It looks like little hills here, and then they process it, and it will become uh, salt. Okay, so I think I prepared a video here for you. Okay, so let's watch this sister of Nataya. to explain to us what are these salt farm in Pichaburi.
Sawadika, my name is Sherry from the Spoon Fork Hut Kitchen. Today is last full day for me in Thailand, and I would like to show you one more thing. It's from the local farm. It's a salt farm from my town. The salt farm, this is salt come from the ocean, and the sun it burn the water, burn the ocean, so make it like separate, make the evaporated, turn to be salt. If the sun already dry all the salt, then add the mineral and all the earth, make this salt taste so much better and so different. And this is how they make the salt. And she's gonna correct this all the salt and then put inside the warehouse. And you can see all the behind me is all this salt. So they put in the warehouse a lot. They even taller than me. It's all salt. Okay. And what make it different for this salt? Because all the mineral or the earth from this town and this area make this salt taste so much different and taste so different than the table salt. They give you more flavor. And I'm planning to buy a little bag of this salt from my town for giveaway for some of my fans. So be the reward. Can be the reward for you.
Okay, so there. At first I thought that that girl is Thai, but she's not Thai, right? She is not Thai. So I was wrong. I misjudged her when she said Sawadika. So I was like, okay, this is Thai. But later in the video, I realized that she is not Thai. Okay, so this is the reality here in Thailand. I've been here. I've been there in Pichaburi province, and this is a very common sightings there. The very big salt farm. It's just like if there is a road, and then you can see the salt farm on this side, and on the other side another salt farm. So have you been there, or have you seen this salt farm before? Mm-hmm. Good, good. What about Natawat? Have you been to Pichaburi lately?
No.
Okay, okay. So I think it's very important that you will visit there sometimes, and I have I have pictures with it. But I want to share something to you as well. There is the, let's say, this is the expensive or the most expensive salt that I know. There is what we call Himalayan salt. Okay, so this Himalayan salt, look at this. This Himalayan salt is a little bit expensive. Okay, it is like color pink something, and of course just by its name we can recognize that it is from Himalayas, right? So of course people believe that there are some minerals on this Himalayan salt, and then they are selling this one 200, 300 to 400 baht. Okay, if you want to try Himalayan salt, you can have I think there is a candy in 7-Eleven. Yeah, there is a candy in 7-Eleven. This one, Himalaya salt, it's only 10 baht. Maybe you want to try this, and if you're going to taste this candy, I like it. You can really feel the saltiness of it. Okay, so it's a good product as well, and it is it is claiming that it is there is a Himalayan salt in it. So if you want to try, you can try. Okay. So let's go back to our PowerPoint. There, perfect. Okay, so there is a video that you can do at home. There is a video that you can do at home. This is like a literal boiling the seawater or the water mixed with salt, and then let's see what happens. Okay.
In this activity, we shall demonstrate how to separate salt solution by the process of evaporation. We have taken a glass of water and we are going to mix a spoon of salt into that. We'll stir it till the salt fully dissolves. Now we are going to pour this salt solution in this vessel and boil it till it evaporates.
Okay, so let's see what will happen here. Just the salt and water, right? And then Natawat is looking at it, that he is thinking, I will try this at home. Yeah, you can try. You can try this. Okay.
As you can see, the water has evaporated, leaving behind a salt.
Okay, so there you can see the salt left in the pot, and the water is no more. Okay, all the water evaporated. Almost all of the water evaporated. Okay, it's done. Okay, so that is how evaporation
Now the
works.
water has fully evaporated, leaving behind a salt. So in this activity we can see how to separate the salt from the salt solution by the process of evaporation.
Okay, do you have any question with this? I watched this one. This is the second time or the third time I watched this video. Then I realized at first he added how many spoon of salt? He added one, right? He added one spoon of salt there. But as you can see here, you notice that there's a lot more of salt. I don't know. Maybe it's a lot or maybe just the same in the beginning. I'm not sure. Yeah, there's a lot more, right? So I don't know. Maybe he added more salt in between because here, or is that here he cut the video, right? So he cut the video right
As you
there.
can see,
No, there he cut the video,
as
and
you
when
can
the
see,
video comes back, there's a lot of salt already. So we don't know. Maybe this Indian guy is doing something funny, but I think it proves the idea that if we will do this one, if Natawat will try to do this at home, the same thing will happen. Now I want to explain something very, very, very important here. Now, if you are going to write, or if you're going to put, what is this? If you're going to cover this thing here, okay, so if you're going to cover this, okay, I will try to cover this, okay. Now, if you're going to cover this thing, and then you are going to, you will not let the steam to come out, and then you will have only one small hole here in the at the center, and you will let this what is that, you're going to put a hose or something, and then you're going to put a baker here. Okay, you're going to put a baker, Then the water that will come here will be the distilled water. You understand? But in this case, the one that he is showing us, it is we cannot see the water, right? Because instead of uh, separating the water and the salt, we can only see the salt because there is we can see the salt only, but the water, it's gone because it evaporated. He didn't collect the water. Interesting part of this, maybe Natawat will be able to do this experiment. You will try to measure how much water you do in the beginning. For example, one full of glass, and then after you do the distillation, let's see if you're going to compare from the beginning and after the water is distilled. You determine if it's the same from the beginning or it's lesser or it's more or something like that. And how does it taste? Maybe it tastes a little bit of saltiness or something like that. So you can do this experiment by your own. Okay. So, do you have any question before we proceed to our practice time? Do you have a question? This one is very simple, right? I'm sure Nataya is smiling because she thinks this is a very, very simple lesson. Well, before we are going to proceed to our practice time, I want to ask you how many separation techniques that we studied already. What are the separation techniques that we studied already? Can you tell me? Without looking your book, let's see. Yes,
Shifting.
shifting. What else?
Filtration.
Nataya,
Filtration.
filtration. What else?
Using magnet.
Using magnets. What else?
Evaporation.
Evaporation. Okay. Evaporation. What else?
Precipitation.
Precipitation. Very good. Precipitation. Okay. Now, in shifting, what does it separate? Shifting separates the
Solid.
solid.
and solid.
Na. Bigger and smaller solids. What about filtration? What does it separate?
Solid.
Solid
Na,
and liquid.
Solid and liquid.
insoluble solid
Solid in liquid.
from liquid. Okay, what about using magnets? What does it separate?
The
Magnetic and
Solid.
oh, no, no.
magnet.
Magnetic and
Non-magnetic.
non-magnetic. Okay. Oh, non-magnetic. What about evaporation? What does it separate?
Insoluble solid from liquid.
Soluble solid from
Liquid.
liquid. Okay, what about precipitation?
Insoluble particles.
Okay, insoluble particle from, or let's say dirt from liquid, right? Dirt from liquid. Okay. So can you give me of a mixture that can be separated by shifting? Can you tell me?
Sand and rock.
Sand and rocks, very good. What about filtration?
Chalk solution.
Chalk solution. What about using magnets? Using magnets?
Metal and wood.
Metal and?
Wood.
Okay. Okay. What about evaporation?
Salt solution.
Salt solution. What about precipitation? Dirt and water, right?
Dirt water.
Okay. So I hope you will remember that because on Wednesday we will have a lot of practice time to do. Okay. Now here, Phi wants to separate a mixture of candies as shown below. So there is orange, blue, green, red, brown, or something. What the most suitable method to separate the candies by color is? A. Sublimation. B. Evaporation. C. Picking them out by hand. Or D. Precipitation. What's the answer? Nata what? Let's see.
Picking them out by hand.
Very good. Very good. Letter C. Picking them out by hand. What about supercrit? A common chemical used to precipitate contaminants in the water is blank. Supercrit, what's your answer? Alum, aluminium, colloid, or bleach?
Alarm.
Very good. What about the next question? Let's ask Parinya. Which of the following statements about evaporation is true? A. Evaporation happens faster at a higher temperatures. Letter B. Evaporation happens is lower at a higher temperatures. Or letter C. Evaporation is not affected by temperature. Or letter D. Evaporation happens only when the liquid is boiling. It's okay if your answer is wrong. Parinya, go. Anybody? Or maybe who wants to answer? Maybe number one, Puti-san. You want to answer? Parinya,
No.
Napichaya. Napichaya, do you want to answer? Anybody? Jirayu, do you want to answer?
I want to answer.
Yes, what's your answer then?
A.
Letter A, very good. This is very simple. Evaporation happens faster at a higher temperature. God, this is very common, very simple. Okay, this one is what we call the red ruby. It is a common dessert in Thailand. How do you call it in Thai? Natawat? How, help me how to do this one. I want to try this. What do you call this in Thai?
ทับทิม
ทับทิมกรอบ
Team crop. Okay, so I want to. How much is this? 20 baht, 30 baht. How much? 10 baht or 5 baht? Okay, so I want to try this one. So this one, it says here, Mint has a bowl of red rubies in coconut milk. She wants only the red rubies in the dessert. Which method can she use? She doesn't want to drink the coconut milk. Letter A, pour the dessert through a sieve. Letter B, pour out the coconut milk. C, carry out filtration. Or letter D, all of the above. What's your answer? Let's ask Chuntida. What's your answer? I want to eat the red rubies only, but I don't like the water or the coconut milk. So what are
D.
we? I'm sorry again.
D.
Very good. Letter D. Correct. Now let's proceed to the next question here. The steps of water purification process are shown below. Which step involves the precipitation technique? A. Solid particles in the water clump together after alum is added. Letter B. Solid particles in the water settle to the bottom of the tank and are removed. Letter C. Water is passed through layers of filters. Or letter D. All of the above. Let's ask Purama. Do you want to answer? What about Jinipa? Do you want to answer here? Apiwit? Satawit? Maybe you want to answer? We have Pirapong, Tanakit, Kemeka. Please turn on your mic and then answer. if you want. Come on. Nobody? Let's ask my friend here. Jirayu? Jirayu, what do you think is the answer?
D.
Again, sorry?
D.
A. Correct, letter A. Okay, what about the next question here? Maybe Supakrit or Napichaya will be able to answer this. Ben wants to dissolve sugar cube. You know what is a sugar cube, right? A sugar and cube, a sugar cube. Okay, what can he do to make the sugar dissolve faster? Two correct answers. I will give this one to Napichaya. Napichaya, please. This is very simple. Two answers.
C.
C and
A.
C and A. Okay, very good. Stir the mixture, and letter C, heat the mixture. A and C. Okay, so I want you to go to page 38. Page 38, and I want you to answer this. I will be giving you maybe 1 minute only to answer this. This one is very simple. It's not as hard as the other things that we answered already. So this one is very simple. And while you are doing that, I will try to check your attendance. Okay? Try to check your attendance. Six slash one. Okay. There, perfect. I can check your attendance now. Today is 0. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 21. Okay. 37, 38, 39. I have 34 as well. Okay. Okay, done. Perfect. I'm done checking your attendance. So you can, what is this? So we can check your work now. We can check your work now. Anybody who wants to, okay, time's up. I want you now to, I will be checking your work now. Okay. Done? Natawat? Chuntida? Dun rapor nataya purama? Done? All right. So let's check. Let's check. What is the answer for number 1? Which of the following mixtures can be separated by using a filter? What's the answer here? Dun rapor, what is your answer? 2 answers, right? Yes, what's your answer? Please, I can't hear your voice. Dun rapor. Go, go, go. It's okay now. A and A and
B.
A and B. Okay, the answers here are, let's see. A, oops. A and D. Oh no, A and uh wait. In your book it says here A and D. Okay, yeah, A and D because this is the filtration. So the answers here is A and D. Okay. So letter A here. Okay, and letter D. Okay. What about number 2? Who wants to answer number 2? Maybe Paradi wants to answer number 2. Paradi, go ahead. What is your answer here? Faraday, can you turn on your mic? Go ahead.
B and D.
B and D. Very good. A mixture of water and sea salt, and a mixture of water soluble copper and a sulfate water. Okay, so the answers here are B and D. Okay, B and D. Thank you for cooperating. Who got 4 over 4? B and D. Oh my God, this is very ugly. Okay, B and D. Okay. Who got 4 over 4? Raise your hand. Raise your hand. Okay, clap your hands, everybody. Who got 4 over 4? Who got 3 over 4? Or whatever your score is. I hope you did your best. Okay, so that's all for today's online learning. Let's have a quick review. These are the vocabulary words that we studied today. Distillation, condensation, evaporation, boiling point, saturated, dissolved seawater, freezing point, salt, and soluble. Okay, so these are the video credits that we've used. Okay, in this presentation, and safety alert. Friendly reminder that we need to stay safe from COVID-19. And right now, we are working at home as well because of this COVID situation. Hope everything will be okay so that we will be able to come back to school, and you will be able to come back to school as well. And then we will be able to see each other again. Okay, so do not leave yet. I will end the recording. Thank you.